Similar triangles. Two triangles are similar if they have the same angles. We are going to use this right angle triangle in order to introduce this concept. And we're going to do so by first drawing a line that is perpendicular to side B. So this line is perpendicular to side B, and also since side A is perpendicular to side B, this line is parallel with side A. Then we are going to identify the intersection of this line with the hypotenuse, side B, and we are also going to use the vertex of the hypotenuse and side B. Using these 3 points, we are going to form a triangle. So now we have the original blue triangle and the new triangle in red. Notice that this is a right angle triangle in which the corresponding 19-degree angle is here, so we can call this gamma, since its 19 degrees is the same value as the one in the blue triangle. We already mentioned that the sum of the angles of a triangle must be 180 degrees. So in this particular case, since the blue triangle has angles alpha, beta, and gamma equals to 180 degrees, the red triangle has angles alpha, gamma, and this unknown angle here must be equal to 180 degrees. It is obvious that this unknown angle will be equal to the angle beta. We can also assess that if we understand parallel lines. Let us now write the law of sines for these triangles. Before we do so, let us define sides for the new triangle. Let's define the hypotenuse for the new triangle to be equal to D, one of the perpendiculars to be equal to E, and the other perpendicular equal to F. So the law of sines, or let's find the sine of angle alpha. The sine of angle alpha will be equal to the opposite side for the original triangle divided by the hypotenuse, and for the new triangle will be equal to the opposite side divided by the hypotenuse. The cosine of angle alpha will be equal to the near perpendicular, which is B for the blue triangle, divided by the hypotenuse, or equal to F, which is the near perpendicular, divided by the hypotenuse for the new triangle. We can also write the sine of beta, and for the blue triangle the sine of beta will be the opposite perpendicular divided by the hypotenuse, and for the new triangle will be the opposite divided by the hypotenuse. The cosine of beta will be equal to the near perpendicular divided by the hypotenuse, and we apply these to both triangles. So what do you observe here? We observe the relationship between the sines and the cosines of the two triangles, and how we can form now relationships between the sides of these triangles. And we can use any one of these relationships in our analysis. So let us now apply the law of sines to both of these triangles. Let us continue our discussion on similar triangles. We form these similar triangles ABC, and triangles with sides D, E, and F. And what we will do now, we will identify and apply the law of sines to both of these triangles, or apply the law of sines to either one of these triangles. It doesn't matter. So if we apply the law of sines on the new triangle, the red triangle, we will have the side E divided by sine of alpha is equal to side F divided by sine of beta. And we're not going to worry about the last angle, gamma, because this one is going to be side D divided by sine of gamma. But we do know that this is the sine of 19 degrees, which is equal to 1. So eventually, this quantity here will be equal to D. So we are going to work with these two ratios. So E divided by sine of alpha. But what is sine of alpha using the information from the original blue triangle? This is equal A divided by the hypotenuse C. Then this will be equal to F divided by sine of beta. But what is sine of beta for the original blue triangle? Sine of beta for the original blue triangle is B over C. So we now need to manipulate these expressions, and these are nested fractions. So we perform the analysis using nested fractions. We find this to be C times E divided by A equals to C times F divided by B. And of course, we can cancel out C from these two expressions, and we end up with the following interesting result. E over A equals F over B. So if we look at this result a little more carefully, we observe that we observe that E over A is the ratio of the two sides that are opposite to angle alpha. And then we observe also the ratio F over B. F over B are the sides that are opposite to angle beta in both triangles. So this is a very interesting result that we are going to use in an example. Of course, when we write this relationship, we have to be careful to write it using the correct opposite sides.